let me explain you why the sphere volume formula is 4 over 3 pi r cubed using calculus. So first of all, we have to get familiar with the equation of a sphere, which is x squared plus y squared plus z squared equals radius squared. Here's the 3D visualization of this equation over here. So in order to find the volume, we need to set up the integrals. And the easiest way to do that is to switch to polar coordinates, where x equals r cosine t, y equals r sine t, x squared plus y squared equals radius squared, or we can call it theta. First of all, in this equation, we have to isolate z and solve for it. So z is going to equal plus minus square root of r squared minus x squared minus y squared. Then we can take a look that x squared plus y squared equals r squared, where we can substitute it. And since the sphere is symmetrical, we can rewrite this part as 2. Therefore, we have the equation of z equals 2 square root r squared minus r squared. Now we have to set up the constraints for our integral. So for r is going to be from 0 to r. Just keep in mind the uppercase and lowercase r are different. R uppercase is a constant while r lowercase is a variable. Constraints for our theta will be from 0 to 2 pi. Therefore, just a full revolution around the origin. Here's how our integral looks like set up. Furthermore, we just have to solve the integral itself. So we do the u substitution, where u equals r squared minus r squared. du is minus 2r dr. We can also flip the signs on two sides, turn it into negative du equals 2r dr. We can find 2r dr right over here, and we just substitute it with negative du, which is going to turn into negative integral of u 1/2 du d theta. The next step for us is to change the limits. So when r lowercase equals 0, u equals r squared, and lowercase r equals r, u equals 0. Then we can swap our limits of integration in order to drop that 0 over here, and our integral is gonna look like this. So our next step is to evaluate the integral with respect to r, which is gonna turn into 2/3 u3 over 2 from 0 to r squared, where we have r squared inside, which cancels out with a 2 in denominator and exponent, and it turns into 2/3 r cubed behind the integral because it's a constant, and we have the integral from 0 to 2 pi d theta. That's a very simple evaluation, so it turns into 2/3 r cubed multiplied by 2 pi. We just do simple algebra and we get 4/3 pi r cubed.